everyone. It's an honor to meet you all day. The topic discussed the post-exploitation research on high-value systems. My name is Linhong Cao. I specialize in code auditing and vulnerability research. This is my preview. Back to the topic itself. Today, we will not focus on vulnerabilities themselves. Instead, we will shift our attention to post-exploitation research. When we have already gained the ability to execute system commands on a target server running critical applications through vulnerabilities or other channels, how can we comprehensively convert and comprehensively collect key information from these applications? Due to the unique nature of these applications, in real attack scenarios, it is often necessary to obtain more comprehensive, convert, and long-term information from the aforementioned high-value systems. Firstly, which systems are considered high-value web applications, such as email servers, gateway device, documents, enterprise knowledge management and collaboration platforms, single sign-on platforms, IT operation management software, domain management team building, and others. We provide examples to illustrate the development and technical implementation of post-exploitation tools in the following application environments. First, let's take Zimbra as an example to explain in detail. The mail server is a core application for the transfer of internet information within companies, enterprise target organization. The mail server itself, user credentials, and other information stored in it are important targets for attackers in penetration attacks. Many attack actions often have the ultimate goal of specific email in the mail server. From the perspective of attackers, the following commonly used post-exploitation functions are summarized for attacking mail servers, such as long-term stable backdoor, main travel, obtaining data routing connections information, detailed information such as user phone address, recording user plaintext passwords, logging in as any user, covering up trace, code repository management platforms. First is the persistence of privilege and the issue of backdoor concealment. In order to enhance the concealment of the backdoor, a memory shell that does not need to be landed is used. And what is memory shell? In the Java Servlet specification, there are three important parts: listener, filter, and servlet. Filter can intercept all requests by configuration. Additionally, mainstream middleware can dynamically add filters, servlets, and listeners to running web application by traversing threads. Zimbra uses JT as the middleware. At the runtime, a filter is injected, and the evil filters exist in the system in memory form. Every request will go through the filter for processing. Normally, business logic is allowed, and only when accessing the Godzilla client will the evil code logic in the filter be triggered. Next, Let's take a closer look at the code logic of this evil filter. The main logic of do filter is as follows. The filter directly executes the received data as Java code. The evil filter will serve as the loader for all subsequent functional payloads. The in-memory shell will become inactive after the machine restarts. To address the issue of failure after reboot, an agent form can be used. However, instead of adding a new landed jar field, it is better to modify an existing field. Of course, the field modification times also need to be changed. Zimbra itself supports plugin extension in terms of functionality, and the following common plugins are installed by default. We put our memory shell injection logic into the plugin, which will be loaded every time in system restarts. Now we have a highly concealed permanent backdoor. Prevent filter failure due to service restart. Modify the Zimbra license success plugin. Adjust to plugin load and initialize up on service restarts. By modifying the plugin's initialization logic, evil filters can be injected every time the service restarts. Now we have a backdoor. How do we obtain the desired data? Zimbra itself provides a service of SOAP API interface for multiplicating emails and users. This is an API document web link. At the same time, the Python Zimbra library is provided, which provides the function of processing and creating Zimbra SOAP requests and sends HTTP requests to the backend for processing. In general, we can use HTTP requests to call SOAP APIs to obtain the desired data, but does it really need to be so conspicuous? Obtaining data information in memory without calling web APIs makes the information acquisition more convenient. Next, let's analyze how to obtain various data information in memory one by one. How to find, mask, and return the data we want from thousands of classes. The entry point can only start from known functions. For example, a lot of namespace exists in the known SOAP API, such as Zimbra account, Zimbra admin, etc. By analyzing the API interface request or call stack, we can finally extract the desired mask. However, during the debug process, there are parameters such as context and the requests that are strongly related to the request, making it a tricky problem to extract a mask or an attribute from a tally nested call stack. Returning to the starting point of the problem, most of the emails and user information we obtain are definitely stored in some from the system. Various type of database or other stranger containers. Can we bypass the complex call stack and interact directly with the database to retrieve data? Yes, but it's not very applicable in Zimbra. After debugging the Zimbra mail interface, it was found that email data mainly used Lucene for search queries, rather than the conventional JDBC database mask. Writing a search logic costs much more than finding the appropriate API to call in code. We analyze each API that we need to be called one by one. First of all is database connection information. JDBC connection information is often stored in a file and in an encrypted manner. Since we can execute code at runtime, why not directly retrieve the decrypted plaintext connection information in memory? After debugging, it is known that the JDBC connection information is stored in the MySQL config class. Functionally, we can directly call the MySQL.getPoolConfig mask to obtain the database attribute information. The execution effect is as follows. This is relatively simple. Zimbra maps each user to a specific accounts class, and the object attributes store detailed information such as each user's phone number, collection, company, department, office, and address. The entry get attributes mask can be used to obtain all attributes. There is no direct interface mask for obtaining the account object. Through analysis of Zimbra code, we can find a class which can be understood as the Zimbra core configuration class. It uniformly manages information such as account, domain, server, and provides interface for access by calling the search directory mask, and all accounts in the system can be obtained. The parameter construction is as follows. After successful login, a value session will finally be generated and returned to client. By debugging the login process, getAuth token mask, the parameter construction and the implementation logic are as follows. On my query interface are Zimbra query class. The mask calls in the HTTP call stack are strictly complex. After trying, it is impossible to find a way to directly call the interface independent of the call stack, removing contents and other parameters. So try to construct operation contacts, search programs, mailbox, etc. Among them, operation contact is the context in the HTTP request. Search program is query parameter. After debugging, it is found that by the manipulating search parameter programs, find, filter, and searching of emails can be achieved. For example, searching by user, constructing mailbox object, searching by date, filtering by keywords, etc. Since the login passwords of each user are stored in the database, using hash encryption algorithm decryption is not possible. The only way to obtain plain text passwords is capturing user login actions in real time. Here, a filter injecting into the GT runtime memory is selected. Login request will go through the logical of record password dot do filter, and the login data package is as follows. In do filter, attempts are made to retrieve the username and password parameters, and then they are recorded in class. The logic of do filter is as follows. The logic of the above code placed in the backdoor shell is somewhat bloated, and there are issues related to being easily discovered during data transmission. We draw inspiration from the idea of web shell. Godzilla supposes executing attribute attribute code logic in the web shell. We only need to enter the bulk code into the Godzilla plugin. The execution of the code and the return of the data will go through the traffic handling and encryption operations of the Godzilla web shell. The captured traffic during the backdoor data transmission process is as follows. Next is Zoho. Zoho Management NG Admin AD Manager Plus is a Microsoft Active Directory management software designed for enterprise users use Windows domains. The software can assist AD administrators and help desk technical in their daily management tasks, such as batch management of user accounts and AD objects, assigning role-based access permissions to help desk technicals, etc. Imagine if we could obtain domain controller information from the software, we could be able to directly take over the entire target domain. In terms of functionality, AD Manager mainly focuses on the domain management. All of its data is stored in the default installed PG circle, except for login password and other encrypted information. The main structure, users, machines, and other information are stored in plain text in the database. Therefore, most of the post-exploitation functions are written for AD Manager, which can be bypass the analysis of web requests, call stack, and directly query the database. Regarding the functionality of this software, we have implemented backdoor functions that support obtain data controller, administrator information, and database stored domain information, obtain database connection information, login information for accounts with the highest privilege, bypassing IP login restrictions, and recording plaintext passwords. There are two methods to receive database information. The database information is stored in the configuration field, field. After analyzing the AD Manager code, it is found that the password can be decrypted. The decryption mask is as follows. The second mask is that the database connection information exists in a specific object during runtime. The username, password, and other information are stored in properties. The implementation logic is as follows. However, there are some problems with decrypting here. From a different perspective, if the administrator fronted can modify the domain controller credentials, then there must be encryption and decryption operations involved when comparing with the old password and storing it in the database. By tracing the call stack, it was found that the runtime get domain data mass directly obtain the plaintext of domain controller password. AD Manager achieves session persistence by storing sessions in the database. Slack is the language. So we can change the database. The certain functional model suppose obtaining all active status session and modifying the session status of the recently logged in user to active. Obtained sessions are as follows. The login authentication of Zoho AD Manager is performed through a web.xml, which calls Tomcat's built-in authentication mechanism for authentication. The code is in authenticator base. The authenticator base calls the rename config the server.xml for login verification. Therefore, we cannot inject a global filter into memory to intercept passwords because the validation logic is performed before the filter and the password field is already encrypted when it is passworded to the server. We continue to follow the login process and find that the password field can be entered the decryption logic during credential validation. At this point, although the password stored in the database is hash encrypted and cannot be decrypted, the user's input parameters can be decrypted by using decrypted mask. Since the filter comes after the login verification, we can try use a listener. After analyze, we found that by injecting a listener into memory, we can successfully intercept the incoming password ciphertext. The above are all the solutions for implementing the functionalities. Now let's revisit another issue. Zoho AD Manager does not support dynamic parsing of fields such as JSP, or does it support dynamic configuration plugin hot logging. Therefore, in order to dynamically inject backdoor logic at runtime, we can only use Java agent technology to dynamically modify loaded or unloaded classes. We utilize the feature to dynamically modify specific mass of specific classes and add our evil backdoor logic to the running memory. Load agent after startup to achieve new proxy operation agent main. Now we can successfully inject shell to memory. As a solution for runtime backdoor injection through Java agent, it is best to avoid adding evil fields to the file systems for long-term backdoor retention. The entry mask for AD Manager is start and run. Analyze its startup call stack. AD Manager calls the default browser to access the login page every time it starts. Start web client execute program. Choosing to modify the execute program to inject backdoor logic is a perfect position. First, inject the backdoor during startup conforms to the injecting timing. Second, the overall function of the application has been fully started, and the context required by the injection logic has been analyzed. In conclusion, the persistent way is to replace jar file advanced AD startup.jar where start web client execute program is located. Finally, let's organize it with a flowchart. Confluence is a professional wiki program. It is knowledge management tool that enable collaboration and knowledge sharing among team members. Its powerful editing and site management features help team members share information and manage projects. Confluence often contains comprehensive records of core company data and is often an important target in per-training testing. In the source code of Confluence, there are logical writing specifications for various functional models, and each function can find independent interfaces, which greatly facilitates the development of post-penetration functions. Most of the scenarios where Confluence is attacked involve exploiting 1 or 0 day vulnerabilities. In history case where vulnerabilities lead to code execution we can inject a memory shell by exploiting the vulnerability, and then deploy our evil plugin to a shell compartment backdoor injection. This way, even after application restarts or vulnerability patches, we still retain access to Confluence. Here is an overview of the attack. The communication data for the backdoor traffic is as follows, showing it has been perfectly encrypted. Due to the time limits, I only select a few representative post-exploitation applications for code and structure analysis, sharing the implementation basic of various post-exploitation functionalities. I proposed a mask for runtime hijacking of web container requests, processing logic, and in protesting highly convert persistent backdoors in memory through deploying highly concealed plugins and using deprecated functionality exploitation. These backdoors are used as loaders to execute payloads in memory, which both the logic and functional payloads of the backdoor deployed in memory. I hope to provide some ideas for the development of post-exploitation tool for other high-value applications, and my tool will continue to be updated in the future. I look forward to seeing the more detailed analyzed article and the source code you plan to publish later. Because my English speaking ability is limited, using Twitter as a contact mask is a good idea. Thank you.